Good afternoon, everyone. Welcome to Eirini Summit and this year allocated with Cloud Foundry Days. My name is Oleksandr Slynko. I work at Pivotal Project Eirini.
And I'm Georgi. I work at SAP, again for Eirini.
And today we'll talk about several things that we want you to know. It's Project Eirini with some minor details, how it works, little bit about Project Quarks and how it works, and then about Kubernetes, a little bit of details and a little bit of debugging. We won't be able to cover everything. We'll give some list of some tutorials at the end, and we'll share the slides after the presentation, so don't need to take a picture of it. So why do you want to know more about Eirini, Quarks, and Kubernetes? First of all, Quarks provides similar operator experience, similar but not the same, and lets you deploy Cloud Foundry on Kubernetes. And developers get identical experience as Bosh deployed Cloud Foundry, Kubernetes deployed Cloud Foundry. Also, Quarks and Eirini provide smaller memory footprint, and Kubernetes adds simpler after-scaling, which you can use in future, not now, but soon. And also, because all the hype, you want to know Kubernetes. So what do we have? We have all these components right on top of Bosh, typical Cloud Foundry installation, and then with with Quarks, you just do like this, click, and ta-da, everything runs on top of Kubernetes. As simple as this, and Quarks does it for you. So what it does, it gets the Bosh release, runs some commands, converts it to Docker image, and then converts it to Kubernetes template, which you can apply to a cluster, run in your cluster. And in order to understand a little bit more, I'll just do a refresher for some Kubernetes details, that primitives that people should know, or if they learn it here today, it would be great. So first is pod. Pod is minimal deployable entity in Kubernetes. It's several containers running together in a single address space. And it's one or more containers. It's ephemeral, so it can be deleted at any time, and has IP address and things. And since it's ephemeral, Kubernetes doesn't check that it's up and running. If it dies, it dies. But it has different primitives that looks at pods are up and running and that multiple pods are running. So in Quarks and in Eirini, we mostly use Stateful Sets, which gives you ordering and also allows to do sticky sessions and allow you to connect disks. And also there are deployments which are not ordered, but we won't cover them in this talk. And as I said, pods are ephemeral, they die all the time. So in order to have the same address, Kubernetes provides primitives called service, which just has the same IP address all the time, and when pods dies and new created, it connects to the new port. It's done by Kubernetes Magic. And one more piece of magic. So in order to serve the traffic all the time, Kubernetes allows you to specify so-called readiness probe. And when pod is ready, let's say you can configure it, let's say application is running or it's listening on a specific port, it's connected to service. If it's not ready, service don't serve any traffic to that port. And it's used both in Quarks and Eirini. So those things, and as a result, all these things, service, stateful set, it's all in this blue box. And I think it looks very good. What do you think, Georgi?
Well, I do agree it's pretty good, but I still see one issue with this image. Does anyone know what it is? Let me help you. It's the presence of Diego. So why is Diego an issue? Well, Diego is a container scheduler. Kubernetes is a container scheduler. So now you have a container scheduler being scheduled by another container scheduler. And what happens when you CF push an app, the request will go to Diego, and Diego will try to schedule this app in a garden container. But since Diego itself is running in a container, what you'll eventually end up with is something like this. So you have your app running in a garden container, which is running in a Docker container, which is running in a Kubernetes pod. And I really hope you see what the issue here is. You have this nasty case of multiple nested containers. It's harder to debug, it's harder to operate. It's just nowhere near a native solution. So what can we do in that case? Well, since Kubernetes is a container scheduler first and foremost, wouldn't it be nice to be able to reuse the same cluster that you use to deploy your Cloud Foundry components in to actually schedule the apps? And that's what Eirini does. And in a nutshell, we can say that Eirini enables Kubernetes to take over scheduling in Cloud Foundry. And now when you CF push an app, this request will go to Eirini, and Eirini will map it to some Kubernetes native objects, and it will let Kubernetes do all the rest. So from an architectural point of view, what will happen is pretty much the same thing, but now you don't have any Diego components, you just have Eirini. And that was the high-level overview of what Quarks and Eirini do. But if you want to be able to understand them better and to operate them, we have to take a closer look under the hood of how these things actually work. And Alex will start by talking a bit about the Quarks Magic.
Yeah, so you probably know how packaging happens in Bosh world with Bosh releases, how communication happens with Bosh DNS, and how sensitive information is stored in CredHub. You don't have anything of it in Kubernetes world. So what you have instead is Docker images, kubedns, and Kubernetes secrets. So let's first talk about images. They generated by a tool called Fusile. It gets Bosh release and generates Docker images and Helm manifest. And how it's done, it does base image stem cell, puts compiled packages, and puts on top of it all the config job scripts and script configs, and as a result, each image is ready to start. It just needs some environment variables to finish the templating. And we'll come to environment variables later. And how do components talk to each other? So Kubernetes provides kubedns and CoreDNS. It's two different components doing the same thing. You can deploy either of them. I think all providers provide them and deploy them by default, one of them by default. And how they work in a nutshell, you have CoreDNS running in the cluster. It talks to Kubernetes API, gets some information, and builds DNS entries. And also it serves as DNS resolver for each Kubernetes pod, for each Kubernetes container. And how those DNS entries are built? So imagine you have service running in same namespace, and as a result, it builds as service.namespace.svc for type of the entity, service in this case, and .cluster name, which is usually cluster local, but not always. And as a result, this DNS name is resolvable inside the cluster, so any component can say gorouter.scf.svc.cluster.local and talk to gorouter. Okay, let's talk about secrets. So Kubernetes doesn't generate secret for you. It has this thing called Kubernetes secret, the secret, where it stores secrets encrypted in etcd database. It's not too secure, but can be used to show off your passwords. And mostly Kubernetes applications require that you have all the secrets provided. You store them somewhere. Luckily for us, Quarks gives secret generation job that generates all the secrets that Cloud Foundry requires and stores them in SCF secret. And as a result, when pods needs to start and get some values, they get those values from this secret, put them in environment variables, and then templating happening, and these secrets are propagated to pods, and they're used inside the pod. So that's overview. Let's talk about Eirini now.
All right, let's talk about Eirini. And just a disclaimer, we won't be able to go through all of the Eirini details because we don't have the time. If you want to know more about Eirini, you should definitely watch all the project update talks that we've had so far. But anyway, as we already said, Eirini is this little mapping layer that glues together Cloud Foundry and Kubernetes when it comes to app scheduling. And as such, it has to be able to map CF-specific things to Kubernetes native objects. And it has to be able to do all of these things and many, many more, but in Kubernetes. And the first thing Eirini does when you CF push an app is to actually create a droplet for the app. And it does that by running staging. And therefore, Eirini creates a Kubernetes job, and it runs the staging process in the container that was created by that job. And you can think about Kubernetes jobs that they're basically the same thing as CF tasks. It's just a process that runs to completion. And just before the staging job actually completes, it uploads the resulting droplet in the bit service component, which we use as a registry that hosts all app images. So let's take a closer look at the staging job. And we can see that it consists of not one, but 3 containers that are run sequentially, and each of them is performing a different thing. The first one is responsible for just downloading the app bits. The builder is the one that's actually doing all the build pack staging, and it produces a droplet at the end. And the uploader is obviously responsible for uploading the droplet to bit service. And you might be wondering, why did we split it that way? Why not just run it in a single container? And there's a reason for that, and that reason is because of security. Since both downloader and uploader are required to have some certificates present on the container, because they need to connect to blob store and bit service, if the builder step was actually running in the same container, then in theory, some custom build pack can access these certificates and can use them for bad things. So that's why we completely shut that off and run it in a separate container. So now that the app is staged, Eirini has to tell Kubernetes to actually schedule it. And it does that by creating a stateful set. And as Alex already explained, stateful sets basically manage a group of objects with identical container spec. And these objects are pods. Now, usually pods consist of one or multiple containers, but in the case of Eirini, it's always one container. And this is the container that's actually running the app. But since it's a container, Kubernetes has to be able to pull the container image from somewhere, and this somewhere is called bit service. If you recall, we uploaded the droplet to bit service at the end of staging. So now bit service can construct this app image by putting the droplet on top of a root fest layer. And the root fest is just a wrapper around CF-Linux FS3. The next 2 things we'd like to mention are publishing routes and crash events. And the reason we're putting them together is because they rely on a common Kubernetes API called Informal API. So how this works is basically you have an Informal instance, and this instance will receive an event every time Kubernetes resource of some type is updated, terminated, or created. And for publishing routes, we have an instance of an Informer running in Eirini, and every time a pod is created, this Informer will get an event for it, and then it will tell Eirini, and Eirini will construct the correct route register message and send it to Go router. Works the other way around too. When a pod is terminated, again, the Eirini knows about it and sends a register message for this app. Crash events work in a very similar way, but this time we have a separate Informer that just watches for crashes, and it tells, again, Eirini, and Eirini will send a crash event for this instance, this time to Cloud Controller. All right, so now that we know how Quarks and Eirini basically work, how do we install this whole Cloud Foundry on top of Kubernetes? And the first thing you need to be familiar with is called Helm. Helm is a package manager for Kubernetes. It's the most widely used package manager for Kubernetes. And when working with Helm, you have to know about 3 main terms. You have to know about Helm charts, which is basically a collection of files, which are called templates, that describe similar Kubernetes resources. Then you have a Helm repository, which is where Helm charts live. And it's just an HTTP server which hosts packaged chart files. It's also important to mention that charts can depend upon other charts. And That's how we deploy Eirini in our environments. We just list Eirini as a dependency of the main CF chart. And the last thing to mention here is a release, which is just a result of a Helm install, which is basically all these templates actually running on the cluster. So how does Helm actually work? Well, Helm consists of two components. There's a Helm CLI, which is running on your local machine, and there's a tiller component, which lives in the cluster. And when you want to upgrade or deploy any Helm chart, the Helm client will actually send this information to the tiller component, and tiller will act on your behalf, and it will call the kube API, and it will create all the desired resources. Now, there are some things you need to be aware of when working with Helm. The first one is that Helm is not that secure by default, and you have to take care of applying the proper security configurations. The next thing is that Helm CLI provides a lot of useful flags. For example, dry run and debug will allow you to test your deployments without actually deploying anything to the cluster. So Helm will still run all the pre-deployed checks, but it wouldn't actually apply anything, so that way you can catch bugs earlier. And last but not least, Helm does templating, and actually templating is a huge part of Helm. It uses a combination of Go templating and some custom functions, and that allows chart maintainers to expose variables, properties that can be overridden by end users, and these properties are usually put in a values YAML file. FYI, there is a Helm version 3 on the way, which is supposed to be a huge improvement over version 2. The biggest difference is that it actually doesn't have a tiller component. The Helm CLI directly communicates with the kube API, but this is still in beta, and it's not very stable, so use at your own risk. So now that we know what Helm actually is, how do we install Cloud Foundry? And the only thing you have to do is run these two Helm installs, which will install 2 Helm charts on your cluster. And the first one will install all the UA components. And in addition to the UA components, it will create a Kubernetes secret, which contains the CA cert for UA, which we'll need in a bit. And once all of these components are running, you can install the rest of Cloud Foundry by installing the CF chart. But for the CF chart, you need a couple of more things. You need to provide a bit service certificate, because bit service requires certificates. And the requirement for these certificates are that they have to be signed by a CA, which is trusted by the Kubernetes cluster. As we said, you need a UA-CA, because a lot of Cloud Foundry components communicate with UA, so they need to have the certificate. And you need to provide a similar values file that was used when deploying UA. And this will result in the rest of the Cloud Foundry components being deployed and eventually running in the cluster. Well, since you have installed Cloud Foundry now, but at some point, you would definitely need to upgrade it. And to see how we can do that, we'll jump to the terminal and see what we can do. All right, do you see? I'll just make it a bit bigger.
Can you see it? If you can't see, just raise your hand, we'll zoom it even more.
Come on.
I think everyone is happy.
All right. So on the right, we can see Cloud Foundry deployed and all of these components actually running in the cluster. And let's say, for example, we want to upgrade the deployment and scale the API group, the Cloud Controller API group instance to 2 instances. Before we do that, let's actually see what we have installed. And first thing we can do is we can say Helm version, just to verify that we're connected to the cluster. And once we are connected to the cluster, we can run Helm list, which will show us all of the releases that are actually deployed on the cluster. If we have internet, of course. Yeah, and we can see that we have 3 instances, 3 releases in this case. First, some IBM Cloud specific stuff, so that's not interesting right now. And then we have SCF and UA releases. And we can see that Helm shows us that the SCF release was deployed using the CF chart version 2.16.4, and the UA release was UA chart 2.17.1. And if you want to download any of these charts and inspect them, we need to know in which repository they're hosted. And in this case, we do know it because we host it. And this is an Eirini repository, which is hosted using GitHub. So the first thing we have to do is tell Helm about it. And once we have it, we can just run Helm search, the name of the repository. And this will tell us all of the Helm charts that are actually served by this repository. And we have just a plain Eirini chart. We have a CF chart which contains all of these CF components, but with Eirini and bit service listed as dependencies. And we have a UA chart, which is pretty standard. And if we want to download any of these charts, we can just run helm fetch with the name of the repository and then / name of the chart. And this will download it locally for us, and we can inspect it. And we have stuff like chart YAML, which is just some general chart information about name, version, description. We have the requirements YAML, which contains all the dependencies and where to find them. It actually points to the repositories that host them. We have the templates directory, which contains all of the resources that will be applied on the cluster. And it has the values file, which contains all the default values for the properties that you can override for this Helm chart. And since we said we wanted to upgrade the SCF, the API group to 2 instances, this information is stored in a sizing section. And the sizing section contains information for like all of the Cloud Foundry components. But in this case, we're interested in the API group. And here we can see what we can override for the API group, which in this case, the thing we want is the count. And to override this, we can use the same values file that was used to actually deploy it in the first place, which I should have here. And this was all the properties that we set initially when we deploy this environment. So what we have to do is we just have to append to it. And we wanted to say that the sizing for API group should be equal to 2. And now the last thing we have to do is actually run Helm upgrade. And for Helm upgrade, we say which release we want to upgrade, which Helm chart we want to use for the upgrade, and obviously we have to provide the file that we just modified. And as we said, it requires some UA and bit service certificates, which I already export this environment variable because it's not that interesting. And if we run Helm upgrade, we should see on the right that in a bit another API group instance should appear after this one. Helm is sometimes slow, especially on conference Wi-Fi, so yeah, it works. And we can see that API group 1 appeared 4 seconds ago, and it's 1 out of 2, but it will become running in a bit. We won't wait for it. So that was how to actually upgrade this CF deployment. Back to the slides.
Yeah, so as you saw, Helm has different deployment mechanism as Bosh. It's very easy to deploy, but it's a little bit more complicated to get artifact because you need to build image and replace in Helm chart. In Bosh, you know, it's like Bosh create release and Bosh deploy, but you'll have to wait for deployment for some time. And Helm doesn't keep the state. It's just no last successful state, but it can know in which state we are right now. So it always supplies diff, and if something goes wrong, it just crashes. Like you know that Bosh task is run on director, and if it's crashed, you just redeploy and Bosh will fix it for you. But let's find out what happens when it crashes. So we'll do one more demo. Thank you, Georgi. And Georgi got working cluster. I unfortunately didn't have that luck. I have broken cluster, and I will use kubectl command, which you will have to learn if you use Kubernetes. Kubectl get pods, I'll get all pods running an SAF namespace. And it hides the pod that it doesn't hide. It's like says blob store 0 of 2 is pending. So this is pending. But why it's pending? You want to find out something went wrong, and let's find out. So the next command, come on, kubectl and describe pod blob store 0. So why it's pending? I want to see information. And when I do describe, it will show me events and say why it's failed. It says failed scheduling, persistent volume claim not found. That shouldn't happen. Kubernetes should create persistent volumes and only then schedule pods, but I broke it. before presentation, so I know what to do. And typical response, if something is broken like this, it's some problem with scheduling, and you need to force reschedule it. And the easiest, not the easiest, I think the only way to do it is just delete the pod. So delete pod blob store, it's deleted, and if I get pods again, I see that it's running, one of two is running. So that means that one part of the pod is running, one container is running, and second is not ready yet. And I see the same for API group. One of two is running. So let's see what happens with API group. Describe pod API group, I'll just do describe, and I see that it's unhealthy. It means it's not ready, and it says readiness probe failed, waiting for monit to be ready. And I want to find out which container is not ready, because there are two containers. That's why I show one of two, and if I scroll a little bit down, and I see containers, API group, and it says ready false here. So that's not ready. That's what's broken. And typically, in regular Kubernetes deployments, I would go to logs. But here it won't work, because current version of Quarks uses Bosh lifecycle and uses monit, and the last thing that I see, it's monit started. So that means that it went through the templating phase, it's something problem with monit, and to find out what's the problem, I have to connect to the pod. So what I will do, I will exec to that pod with that command, and I will just set monit summary. Now you icon do Bosh SSH, and I see that post start does not exist, and why does it? Maybe logs will tell me something. So I will go to warwick up syslog date, syslog post start. This is currently Bosh structure. This won't be after new version of Quarks, but it is what it is right now. So if I see it, it says like, oh my God, some stack trace, some terrible stack trace. And I know this stack trace because it's backend copy when you have stackless build packs and probably stackful build packs, it crashes. So unfortunately, I'll have to fix it the hard way. I'll just delete build packs with the stack, and I do bin config console, and I just delete this build pack with the stack, and it will proceed. Copy know about this issue. I hope they will fix it, or maybe they'll point it as not fixable. So if I check it, I can see that there's definitely one build pack with the stack. If I do delete, it will delete it. I just exit, monit summary. Okay, I need to monit start, probably post start. Okay, if I do monit summary, it's running accessible. So if I just exit and do get pods, so I see that API group is 2 of 2, it's running. So everything is running, everything is ready, cluster is healthy. And also basic minimal things that I would like to learn, like some debugging summary. kubectl get pods to get all the pods, and there are other resources such as kubectl get PVC to get volumes and maybe services. Then describe pod, and you can describe any object and describe pod and see what's happening. Then logs to get logs and exec to connect to it. And some issues that we found while we operated Quarks in last, almost a year. Wow. So first, storage classes. Kubernetes allows to specify default storage class, and sometimes it's NFS based. And if you don't pass storage class, it will use default storage class. And Cloud Foundry needs MySQL. MySQL doesn't work with an NFS, so it might start and then start crashing, might be very slow. Take a look that you don't use NFS storage class. Second thing is sort rotation. Check the Quarks documentation, it has some flags, but important, backup your Kubernetes secret after each deployment. There is no backup for you, so do it, because we had a couple cases where secret got regenerated. Maybe we done something wrong, and we had to get backup, so we had to delete whole cluster and deploy it from scratch. So do backups. Then stackless build packs, as I showed, Quarks uses stackless build packs. If you try to upgrade build pack, you'll update it with stackful, or I know how it's called, and it will crash during the upgrade. Rootfs, Eirini uses only CF Linux FS3 rootfs. There is a PR to use different rootfs, but anyway, Eirini will only use single rootfs for some time. And then this command that we had to learn, that it upgrades with force, it deletes all resources and creates them again. It might cause up downtime, super unsafe, but might help you in case of troubles.
All right, and the last thing we'd like to mention today is Eirini X. And thanks to the good people at SUSE, this is a new extensions library for Eirini. It allows you to create specifically extensions for Eirini using directly the Kubernetes API without actually touching any of the Eirini code. And there are multiple extensions developed already for that, again, by the SUSE people. And if you want to find out more about it, you're in luck, because exactly after our session, Vlad and Ettore have a session about this. So if you're interested in that, you should go watch them. Another thing to mention is we have office hours. Eirini has office hours. They happen on first Monday of every month at these times. So if you have any questions, problems, or you just want to chat with us, you're welcome to join. You can find more information about it in the Slack channel, the Eirini Dev Slack channel, and we also post the link to the meeting there. Some useful links if you download the slides later for Kubernetes. There are a lot of more resources out there, but these are the ones that you can use to start. And that was it from us. Thank you very much. And I'm not sure if you have time for questions, but in case we don't, you can always catch us later.
Everyone, like